Good morning all, time for another video with PCBs in it, supplied by JLCPCB. So what do we have in the box? We have a yellow PCB, and today's free magnifier gift is the yellow intelligent sort of ruler stroke magnifier. But the printed circuit board is relatively small, and it's an adjunct to my black VU meter, 10 LED with the green, yellow and red LEDs, providing the rectification of the audio source so that this thing can properly display peak levels. So let's take a little look at this one, which, as I say, is glorious yellow. My first yellow PCB, and I'll explain why it's yellow momentarily. So let's have a look at what's on this board. Well, not an awful lot. There's a TL082, that's a dual JFET input op amp. Oh, there's the name of the board, it's Peak Detect. So it rectifies and smooths the audio signal and then puts it onto the LM3915. This is still logarithmic, but it's effectively getting a DC, a varying DC input, so that we can use this in bar and dot mode. When you get these LM3915 kits from China and you attempt to use them in dot mode, it doesn't really work. I think I've covered that in a video before, but anyway. Also on here, we have a socket here. Now this is an RCA socket, a phono socket, sitting on one of my little daughter boards, and I use this dual inline 8-pin footprint for all my audio sockets. It's just a convenient footprint to use, and it anchors the socket down with lots and lots of contact points, so it's nice and solid. Input capacitor here to what would it be, DC block the incoming signal. It's quite a high value capacitor, so it lets low frequencies in perfectly well. 4 diodes on here for the rectification, some resistors, 4-pin JST, which has the power supplies, plus 12, ground, minus 12, and 5 volts. And 5 volts is used to send a signal, is used to power the LEDs, so 5 volts gets transferred out to this board. That's the sort of sample and hold. It's not really sample and hold, but it's the low pass parallel capacitance, which holds the peak level so that it pushes up rapidly to the peak level and then drops down fairly gradually. That's what that 470N does. And then the rectified and smoothed signal goes out to these 4 connection points. And this is where the 2 boards mate together. Well, let's see if it's going to work. Now, don't know whether you remember this, but this board had various issues, not least of which was the fact that tracks had bashed into the ground plane and I had to carve them back. I've actually made 2 of these because the Vocoder project that these go in requires 2, so I've got 2 already. The other one was this board sits on these 4 pins, but it kind of fouled on that chip. Let's actually come back in for this. And so I had to cut these at an angle, and then this board has to be put in a sort of carefully considered way. Focus has just come in, excellent. Don't need to stop the shot. So that needs to go in at that angle. Signal and ground go through those 2 holes. Yeah, that works because you can slightly bend the pins. Then it tips to that angle. And yes, I can just about get 5 volts and 12 volts. I probably am going to need to slightly nudge these into their holes. And yes, it goes in, and it affords a little bit of adjustment height-wise. So you can set the height of the LED board relative to this board, which will be anchored side by side to other boards in the project. Of course, you've got a rotational alignment, a small amount of rotational alignment. Let's see it from the front. We can rotate it like that, height like that, and the in and out is afforded by this board sitting next to its fellow boards, and it can slide backwards and forwards that way. So that all looks pretty good. So in this video, what I'm going to do is actually assemble two of these, get them onto these two things, pass, I suppose actually I could put a stereo signal into the two inputs, just so that we've got stereo for the moment. That's not how these will be used in the final project. But yeah, let's get these built and get some signals into them and see that they work. So here's how it's going to mount on the final vocoder project. It's simply going to sit between its two neighbouring boards, and I'm going to put 2.5mm, because this space here is 1/10 of an inch. So 2.5mm nylon nuts and bolts just in there somewhere, and then this can slide in and out, which sets how deeply the LEDs poke through the front panel. And as I say, the pins on this black board allow a little bit of rotational alignment, but only prior to soldering it. Once it's soldered, that alignment is no longer there, but you will just have that one final alignment of in and out. This will have a RCA jack very similar to these, and there'll be a little loop wire running around there, taking the output from the relevant board into the LED bar graph, and then the other one sits here, and it's exactly the same situation. The boards will slide in and out of there. Now, why did I go for yellow when all the other boards are green? Well, that's because yellow is my color code for revision 2 PCBs. You see, here's the revision 1 PCB. It's got all the LEDs on there, and that kind of went like that. But this board is fixed in size. It couldn't be any bigger because it couldn't be any wider, couldn't be any taller. And it was very cramped. It was very difficult getting all the parts on. That socket was in a very peculiar orientation. And although I put holes on these boards that were kind of close, there was no actual proper mounting idea for this. And in the end, I just decided this is no good. Let's do a Rev 2 PCB. Here is the Rev 2 PCB. It now sits alongside its fellow neighbour boards and slides in and out and has nylon nuts and bolts. And so yellow is Rev 2. Why is yellow Rev 2? Well, I was trying to think of a scheme where green could be 1, and some very, very clever person, and I can't remember who it was, and I'm ever so sorry, said, well, why don't you go with the numbers, the colours on your actual display board? So green is 1, yellow is 2, and red is 3. So revision 2 boards are yellow, and I think a couple more boards on that panel will go to revision 2 because there are issues with them. And if I go to revision 3, it'll be a red PCB. The only other yellow PCB that I remember is this one, which is the AD584, which is a voltage reference, and you can set this to 10 volts, 7.5, 5, and 2.5. I must use this actually at some point to calibrate my digital multimeters. Now this has got a ground plane solid copper area on both sides, so it looks slightly different to the rather sort of translucent fiberglass side of my board. But this side, oh, there is a slight color difference. This is a bit more mustardy. So let's make a couple of these boards up, and then I can make a little stereo VU meter. Now I need to find an audio source. I've got my Rca MP3 player, this thing, which I can use for stereo audio. So let's get the soldering iron warmed up. That plugs into this Rca. Well, it's a sort of voltage fuel gauge thing, but it's I put a plug in it, a socket in it, so that I can connect it to a Rca power tool battery and run my iron off sort of 20 volts ish. So first things first, the resistors. Now they're all either 100k or 200k. That should be easy to dig those out. Interesting. Oh no, there's a 1k there. Interestingly, the diodes I've just marked D1 to D4, but they're pretty obviously 1N4148. Well, they are 1N4148. So let's get all that lot soldered in on both boards. Just a quick check of these 200k resistors with the magnifying glass. Red, black, black, orange, 200. Yes. If you're interested in the circuit diagram for this. Oh, I think I might have bridged over onto the ground plane there. It's in the LM3915 datasheet where it shows you options for rectifiers. I'll print that out. Let's have a quick look. So here we are, LM3915 dot or bar display driver. This is the chip with the LEDs and a few other components. Now that circuit is effectively what I've got on my black PCB. There's the chip, a couple of resistors, a capacitor, and the 10 LEDs. Now if you go further through this data sheet, we come to this, which is application hints, the precision full wave peak detector. We've got an LF353, which is a dual JFET input op amp. We've got the 4 diodes here, lots of 100k and 200k resistors, the 1k resistor there, the hold capacitor, or at least the peak voltage hold capacitor, 0.47 or 470 nanofarads, and a DC blocking input capacitor. They've put 0.2. I've got 220 nanofarads. So this is the circuit diagram of my yellow board, and it's in the LM3915 datasheet. So 100Ks, I will need 6 of these. 2, 4, 6. That'll do. So I think what I'm going to do with this Ryobi MP3 player, because I don't listen to much music, I'm not really a fan of music, which might sound odd, but there it is. I think I might load it up with a load of copyright-free tracks from the YouTube copyright-free audio library, and that'll give me the ability to pump it into from this device into any sort of audio circuit I make in future, safe in the knowledge that anything I play will be copyright free and therefore in no danger of a copyright strike. The one thing I'm a little bit uncertain about is data sheets. I mean, most of them are marked copyright, but surely those companies would want people to see the content of their data sheets. It's a grey area. So that's all the resistors in. Now for the 1N4 and 48 diodes, just get a whole load of those. Next to go in are the 2 TLO82 dual op amps and some Rca Sockets, which I'm going to use these single inline turned pin strips. I think I might put the JST sockets, or are they plugs, and the 1 microfarad tantalums in next. Well, I found these 3.3 microfarads, which I've got thousands of. I bought a silly number of them. I'm going to put those in. It says 1 mic, but it doesn't really matter, does it? I mean, the more smoothing, the better. Now for the audio capacitors. Well, one's the audio input capacitor, DC blocking, it lets AC through. It's a big value, 220 nanofarads, 224. I've got a couple of those. I could only find one 474, which is the voltage hold capacitor. This holds the voltage to set the peak level on here, and then as the voltage drains away from that capacitor, this will come down. I could only find one, as I say, but I've got these 334s. Now, 470 nanofarad, 330 nanofarads. The only difference is the rate at which it's going to drop back. These will be perfectly fine. I'm going to shove them in. So all that needs to go on these two boards now are the Rca sockets. Now they fit on Rca daughter boards, which are green. That's going to upset the look of it ever so slightly. Let's break some of these apart. I'll need 2 of these, those 2, snap them into singles, find some Rca sockets and get those on the boards. Yes, now I remember I had to cut these connections down a bit on the Rca sockets. Also, I think I need to carve a bit of the plastic away because it fouls the 8 pins, the sort of DuPont 0.1 inch header pins. So I'll just work this with the knife a little bit. So I'm going to solder these in, the pins into these little adapter boards. Can't get rid of that little bit of solder. inner breadboard here so that it all is square. I'm going to try and solder these quite lightly. I don't want too much of a mound. Actually, I'm not going to be able to control that, I don't think. The mound is what it is. And then the RCA sockets solder onto these boards, and I've got to try and get the soldering iron between the rows of pins on the other side to solder those on. Well, I thought you might like to see this. It's a little bit tricky. Got to get the iron and the solder in there. This one's not too bad because it's got a very thin slot. This one, and I think I'm going to have to turn it around, because the leg has got that sort of Z bend in it, or bend in it. I went for a wider slot diameter, so I just want to fill that with solder. That looks pretty good to me. Let's have a close look at that. And it looks like that, which I'm entirely happy with. And you can see there where the two tracks go. They go to two of the corner pins on that 8-pin array. This magnifying glass looks very mucky. Oh yes, it's all covered in dust. I just opened the blinds because it had gone really dark, and now the sun's come back out. Oh, and now it's gone back in again. Perhaps I'll leave the blinds just for 1 second while I solder these 8 pins in. Only 2 of them, of course, are electrically relevant, but the 8 of them make the thing a little bit more mechanically solid, would you say? Oh, this one's the ground one. That's going to take a little bit more heat, but I'm going to do all 8 so this thing can never ever move. Here comes the sun again. Oh wow, very bright sunshine. Down comes the blind. That's better. Right, this one has to go on here. Which way around does it go? Yeah, it goes where it says RCA, doesn't it? Of course it does. Good, let's solder that one up. And well, that's it. My boards are done. Here they are, fully populated with the op amp and the components and the connectors and the power connectors. Now I built this. Oh, it's got the batteries connected, which is the little 12012 generator from 5 volts, and 5 volts also runs up into my power distribution, because I'm getting more and more of these boards now that I need to distribute power to. I didn't have any JST to JSTs, so I actually crimped on 4 of the little JST XH crimp connectors, and it nearly drove me completely potty. But I do need to make another of these cables because I want to power both of these up from this power distribution. You can see 2 of them are the 4 pins which have the 5 volts in addition to 12012. Those 2 of course are for the LED bar graph modules, because the LEDs require 5 volts. So that's that. Now the next thing is I need to do this little bit of dexterity thing where I have to tip the board over at an angle to get it onto those first 2 pins. Let's see if I can do that. Yeah, that's gone on. Tip it then the other way to get it onto these 2 pins. Ooh, bit of scrapery going on there. Is it going to go through those holes? Yes. And there it is. The 4 pins are on. Now I'm hoping, because I don't really want to solder these yet, that there'll be enough connection between the pins and the through-plated holes that this will kind of work while it's loose. I hope so. Well, I suppose the first thing I can do is connect the single cable that I do have onto my module, like so. That's the 3 power supplies. I can switch that on. Now let's see if this does anything. Ah, right, I've got, it's going to be a problem with these loose connections, I guess. Let me just turn that off and on again. Yes, I'm not really seeing that pulse. But anyway, I need to get some audio in here, so let's get the MP3 player. Yeah, if I can remember how to use this thing, I think you have to press and hold play. Yes, that looks like it. And then that plugs into there. And now I've got stereo coming in through here. So one of these, and I assume it's playing, can go into my phono. Oh, that's a bit tight. Oh! And we have a signal coming through there. Now we can't hear it. And that's probably a good thing because I don't know what's on here. In fact, I got a funny feeling it's Alan Parsons' project. So is that a copyright violation? Knowing that it's an Alan Parsons project song and being able to see it move? No, probably not. But whatever that is, it's not loud enough to go into the red. So let's go on a track. Does that go on a track? Yes, it goes on a track. Still not loud enough to go into the red. So I think what I'm going to do is try and find the cable for this thing, plug it into my PC, load a few copyright-free music tracks onto it, hope that some of them are a bit louder than this. And what I can do is plug the other one into an audio amplifier just so that we can hear it. So I'll do that now. Well, now, it seems that I've already loaded some copyright-free music on this thing. I've now put the second channel into the powered speaker, which is on the floor, because it's quite loud. Curiously, though, it's not quite loud enough to send this thing into the red. So let's just start playing something, which is one of these quite loud, bouncy tracks. And it's only just hitting the top green. It's not actually driving the amber, the yellow, or the reds. And I've got various tracks on here. And some of them are quite loud, but not loud enough to take this. I'm not sure what the voltage level of this is. I've got a funny feeling that the vocoder is something like 2 volts peak to peak internally. That one's far too quiet. That one's too quiet. That's quite loud. Still not loud enough though. Okay, so maybe listening to this is not the answer. Perhaps I'll get the second one of these powered up. Now I'm going to need a multi 4-way cable with a female plug at each end. But the little JST connectors are so fiddly and tiny, they drive you mad. Let me have a think about this. Yeah, these things. And it's really not possible to solder these. I wanted to solder them, but you would have to be soldering very, very close to the wire entry. Let me get in a bit closer. So these things have a sort of springy leaf at the point where the pin goes in. Then you can see the first set of wings, which is where you have to close them over the wires, and then the second set of wings near the sort of metal strip that they're attached to push into the insulation. But if you attempt to solder on that sort of smaller set of wings, you're very close to where this spring terminal is, and if any solder gets on that, of course, it's going to interfere with the spring effect. So really these have to be crimped, and it's really hard to do without the crimp tool, just using a pair of pliers. Now the sequence of these as supplied is not correct. I need red on pin 1 for positive 12, black for ground, so red and black need to swap over, and then I need yellow, white, and I've got white, yellow, so yellow and white need to swap over. So what I think I might do is I'll swap these over, and then I'll tack 2 of these end to end, but I've got to make sure these don't short. Do I want to go to all the trouble of putting little insulating sleeves on? I probably do. Well, after a lot of very foul language, I managed to put 4 crimp terminals onto these, very badly, but probably good enough for this. So here's a live connect up. I've not tested this. So let's connect that into the other 4-pin power thing. Oh, that looks good. We need a louder track. Let's try the next track. That's a louder track. Now we're looking for differences that highlight the fact that these are actually 2 different stereo channels. That track obviously doesn't have much in the way of stereo difference. Let's try another one. Obviously, because I'm using both channels, is there a bit of stereo difference there? Possibly. Maybe I need a slightly lower camera angle. How's that? Can you see the stereo difference? Yeah, I think we can see that there are slight differences between the left and right channels. Yeah. Anyway, they're both working. I can't get them into the red because I just can't get enough voltage out of my MP3 player. Let's go to the next track. That's a very quiet one, which started on that channel and now has moved to both. But they're working and I'm actually happy with that. One thing I didn't do is put these into dot mode, so let's pull the link off. That one's in dot mode. Let's pull the link off of this one. Oh no, I said off of. There's no such word off of. Oh, what's happened here? Oh yeah, there we go. I mean, these haven't been soldered yet, so they're a bit iffy. But yeah, those two are now in dot mode. Let's just move the wires so that you can see them. Should we try and find a louder track, because that one's not very loud. That one's better. And the dot mode does a little bit of overlap, so that you can never have an off situation, whereas you do get a double on situation, if you see what I mean. But yeah, that's dot mode, which also works. I haven't managed to drive the red LEDs yet, but I'm sure they're fine. If the green ones work, I'm sure the red ones do. I think that's great. I think those are ready to fit onto the Vocoder front panel when my 2.5mm nylon nuts and bolts arrive. But for today, cheerio.